So the first thing we're going to do is start with the positives, and what I identified as some positives was that your passing rate. If I looked at it from the beginning of the semester with January, those first 2 weeks were a little rough. They were like around 41%. And as I looked at it right now, it's like right around 73. So just really, really quick, because I'm also dealing with teachers whose grades or passing rates are not increasing at all. So what are you doing to improve those grades?
So it's really just like making sure that students are aware of what assignments they're missing and then making those available for students to get for makeups. Like just printing out grade sheets from Power School. And so it has like all their exit tickets, all of their LifeWorks.
Yeah.
And so then they can go through and figure out like what exit tickets do I need to fix, what LifeWorks do I need to get and turn in. And then I've got a binder of exit tickets and LifeWork copies that they can just go and grab.
What's your extension as far as deadlines?
So for me, like they can turn stuff up like the way I feel about it is like we do all of this stuff to get you ready for the IA. So like up until the IA, you can turn in makeup work.
Wow.
And like I don't want to like I'll take it for full credit for LifeWork and exit tickets because like I don't want to disincentivize doing the work.
Yeah.
And so like if they don't turn it in on time, like incentivizing turning it in on time as opposed to disincentivizing turning it in late. So like if they do 5 assignments in a row on time, they get a LifeWork pass, and so like that's the incentive to actually get it done on time, and then the incentive to get it done period is like they can still get credit. And the other big thing is just like making sure that kids can do quiz retakes. So like getting them graded, getting them passed back. And for quiz retakes, they can earn back 80% of the points that they missed. So like if they missed 10 points and they turn it back in and they fix all their mistakes, then they can earn 8 of those 10 points back.
Is this grade level or just you?
This is just me. Other people have different
procedures.
Exactly. Yeah. And so like a lot of that is just kind of like my personal philosophy about like homework and work completion and stuff like that. It's just like the reason I give you the work is it's for a reason. It's to help you get ready for the test.
Yeah.
It's like why would I not take it late? Like as long as we haven't taken the test yet, like it's still beneficial for you to do it. So
I want to follow up with you later about. Do you have that plan written out, or that's just something?
I don't have it written. It's just like been the same for a long time.
That is. I'm going to steal that.
Cool.
Today I want to focus in on deep dive into one particular standard. The standard was developing and use a model to describe the role of gravity and motion within galaxies.
Yep.
The cross-cutting concepts was using charts and images to identify patterns.
Yep.
Right. So my deep dive is on. Got it. It's on question 25. A couple things to just put out there as for. I chose that because of the mastery percentage. It was the lowest. One thing that I did notice is that a lot of students didn't earn any points. And that was for a lot of reasons that I personally saw.
Yeah.
One, students left it blank.
Yep.
Okay, I saw that. And then others, there were some statements that they made that was just really, really far off.
Right.
11 scholars earned 1 point, 4 earned 2 points, and 17 did not answer the question.
Which is actually a lot fewer than I was expecting for this question.
Yeah.
Left it blank, so
yeah,
that's good.
So like for number 25, in the first box, what should students know or be able to show as far as mastering on this question?
It's like, what would the exemplar answer be?
What should they know? To answer number 25, what
do they need to know?
Yep.
So they need to know, like, first off, I think like the main breakdown is they need to know how to read scientific notation.
Okay, hold on 1 second. And what do you mean about scientific notation?
So they need to know that like when the exponent number gets bigger, it doesn't matter what the number in front is. Like a bigger exponent is always going to be a bigger number. And so like students were just comparing the coefficient number out front and coming to the wrong conclusions because they didn't know how to read the scientific notation. So they need to read scientific notation. They need to be able to identify patterns.
So, okay, they need to know, identify patterns. I'm going to come back to the point that you just made in reference to scientific notation and the trend, the gap that you saw. I'm going to come back to that one. So you said identify patterns. Keep going.
So you need to compare like two sets of data. I guess like also they need to be able to identify which sets of data to compare.
Identify correct. All right, so students need to know scientific notation. They need to know that when the exponent gets bigger, the number itself gets bigger. Let me scroll down to what I noticed as well.
Yep.
So then where is it? So if I say, what are the key gaps? You would identify the key gaps as well.
The main one is just like.
Talk a little slow for me. I'm writing this down.
So is not knowing scientific notation.
Not knowing scientific notation.
Yeah.
All right. And in reference to what the data showed, what was the trend in that gap? You talked about it earlier. You said students only focus on the coefficient.
Oh,
What
yeah.
did you say?
Yeah. So they were just thinking that like if the coefficient gets bigger, the number is bigger, and they weren't looking at the exponent. And so like they were actually trying to use the evidence in the table, but they were having a little bit of cognitive dissonance because like they know that Mercury has a smaller mass than Jupiter,
Right.
but they look at this, if you just look at the coefficients, like Mercury is 3.3 and Jupiter is 1.9, and so they'd be like, wait, that's not right. And so then that's where things kind of ground to a halt. And so like students that ask questions about this, like I was able to direct them to the correct numbers to look at for scientific notation. Once I figured out that nobody knew scientific notation.
So then, so would you say that these gaps, not knowing scientific notation, it's kind of right.
Yeah.
And if the coefficient gets bigger, the number gets bigger. Would you say that those gaps are the key misconceptions, or would you add that there are some more misconceptions?
I feel like it would be, I'm sure that there are more misconceptions, but I feel like it's hard to see those because these are so big. And so it's hard to see what else is missing.
Yeah.
Because if we had just been able to like just get rid of the scientific notation completely, or have the coefficients all be like to the same. Yeah. So if this was like maybe instead of kilograms, if this was like billions of kilograms or trillions of kilograms, and so then you just have like a number here.
Yeah.
Instead of a number in scientific notation. My guess is that the performance on this question would go up significantly. Because I think like the other thing that's happening here is this question is the culmination of like a series of questions,
Yep.
all about
23.
trying to identify patterns.
Yep. 23 and 24. Yep.
And so like 23 and 24 are slightly better because like the performance is slightly better because like we talked about these patterns specifically in class and like how mass and gravitational force change like as distance from the sun changes and things like that. And so they know those relationships, and so they were able to earn some points just like stating those relationships, even if they didn't earn all the points by actually like citing evidence.
So you're saying that you guys talked about the mass versus gravity, mass distance versus gravity. You talked about that.
So we talked about like those relationships and how they affect each other, and so like a lot of students knew that.
Yeah.
Like it was just, again, like that cognitive dissonance between like trying to make sense of the numbers and trying to make that fit with the patterns that they know should be true.
So in reference to doing better on numbers 23 and 24, did they do better because they were able to look at the data table and pull that, or they just recalled the
They
information?
were able to do better because it was only one relationship. So it was like mass and distance from the sun, and then gravity and distance from the sun.
Yeah.
Or
Yeah.
So it's just like
This-
relationship
this is-
between two
variables there.
variables, exactly. And so then they were able to, yes, like they were able to recall that relationship.
Okay.
And so a lot of them, like, I think, again, we're just like got really confused by the numbers, and we're trying to make what they know to be true from class fit with numbers that they think are going against that, if that makes sense.
So it makes perfect sense. So
Okay.
like me, knowing what we know now, looking at this particular data table, which I'm going to assume that they're going to see on the state test, how will we go about like reteaching this particular skill,
Right.
this particular gap? Where would you start first?
So scientific notation is being taught in math this coming up units.
Okay.
And so, like, this would be a good kind of like jumping off point for reinforcing what's going on in math, is taking a look at something like this. And then the other thing that I would probably have them do is really start to kind of like actually make annotations about patterns that they see, right? So as the distance increases, right? So then you can look at, okay, so the mass.
So do me a favor.
Yeah.
Because you're getting to what I want you to do on
Okay.
this page right
Got
here.
it.
I want you to literally do your think alouds.
Okay.
Your thinking out loud. Fill up this whole page. I'm just going to just watch.
All right.
And you start with first all the way to the end, and you can talk it out just like as you were doing.
All right. So whenever I look at a data table and I'm trying to find patterns or relationships, it always helps to look at each individual variable on its own and find a pattern there. So if we start with distance from the sun, and the pattern is like as we go through the planets, the distance increases. So we can mark that on the table, right? As we go down, the distance increases. That one's easy.
Okay.
So the next thing is we have to find mass. Oh, here's our question. I was looking at the wrong one.
It was.
So we're looking at mass and gravity. Yeah. And we're trying to find things that don't fit.
There
Right?
we
So
go.
like, let's
There we
just
go.
look at mass first, right? So, okay, so as mass, right, it looks like in general, not always, right? There's some exceptions, but in general, we start off with a smaller mass because we know the exponent is the most important. So that's going to be smaller. And as we go, right, we're getting a little bit bigger. That one's an exception, right? And we're going down. And again, we have a couple of things that don't fit the pattern, but in general, these out here are bigger and closer to the sun is smaller. So as we go down, in general, we see an increase in mass. So for mass, as we go down the table, it also increases with some exceptions. And then we go to gravity. Right? So again, gravity is something we're looking for a pattern. And so as we go down here, right, we start with things in the 22 exponent, so pretty big, right? And as we drop down, we get to 21. Jupiter, we know, is an exception. It's way up to 23. But then we start to go back down again, 22, 21, 20, right? So in general, as we start to get away from the sun, as our distance increases, gravity is getting smaller. So for gravity, it's going to decrease with exceptions. And so this is where we start to figure out what are these exceptions. So it's asking,
There we go. There we go.
does the data not follow the trend? So that not following the trends is our exceptions. So we noted a couple of exceptions. We said Jupiter was a big exception, right? Has a much bigger mass. And we look over at gravity, and gravity is much bigger than we would expect. So our trend is decreasing. All of a sudden we get to Jupiter and it jumps way up, right? So we know that Jupiter has a higher mass than expected, and higher gravity than our trend. So it doesn't fit our trend because it's a higher mass, right? And we have more gravity there. So our trend is decreasing gravity, right? But Jupiter's gravity is more. How can we explain that? Well, if we just look over to our mass,
There we go.
right? Our mass is way bigger. So we know that both of those have an effect, right? The distance and mass both have an effect on gravity. So even though our distance is increasing, which should make our gravity get smaller, our mass here jumped way up, which gives us more gravity. So, and that would be an acceptable answer.
So how would you infuse the gap with the scientific notation?
So
What would you?
I think probably just for starting off with,
Okay.
like looking at patterns. If we have scientific notation and we're looking at patterns, like just start by looking at the exponent. Like don't even worry about the number in front. Just start by looking at the
Okay.
exponent. And if we have to, you can look at the number in front. And I think the other big thing here is that patterns aren't always going to be like every single one isn't always going to fit. And so we may have to look in general. We may have to look
For
like
general,
overall.
look for general trends.
So not everything follows all the time.
And honestly, I love how you start that because that's where we got to start. We got to say that first. Trends, like if I was to poll all of you guys here, like you guys would not follow all of the trends as far as being adolescents.
Right.
You know what I'm saying? So I think that's a really good stamp there. Doing this type of thinking out loud for the scholars, like what would be the impact of it?
So I always think that think alouds are really powerful, especially when you have a really kind of like fundamental gap of like people not knowing how to approach a problem, which is kind of what I feel like happened here. Because one of the things that happens is like students don't know how to answer a question because like they literally like don't know what they should be thinking about. And so doing a think aloud and talking about how like this is how like good scientists, like this is how their brain works when they're looking for these types of things, when they see this type of problem, when they're reading these types of questions, like this is what's happening inside of their brain. So that's one of the things that I try to do a lot of during like do now reviews when we have like stuff that aligns with I-8 questions or stuff that aligns with like questions from 6th and 7th grade that they might not remember, is just like really like being specific and modeling like when I look at this problem, if I don't know the answer, like these are the things that I do to make sure that I can get to the answer. So
like thinking about, because earlier you talked about that in math class they're going to be focusing on scientific notation. What is that, this week or
this unit sometime?
This unit sometime.
Yeah.
So like thinking about that, so they're going to give me reps over there. But now I'm thinking about when would you have time to reteach this? Because this is transferable.
So this, I mean, I feel like this is going to be most beneficial, like leading up to the map test. Because like they're not going to see anything like this in at least module 5. They won't. I haven't looked in detail at module 4, which we're doing also this unit. And so I feel like this might be something that we can definitely spend a day or two doing similar problems like this during performance training. Or even there's, I think, flex days built in for like the review for the practice map test at the end of the unit before they do that. So
we're talking about 2 months, 2 months out at least.
so it'll be
February.
yeah. So like that's kind of the tricky part of the way the science curriculum works is like a lot of times they just like there's nothing. Like finding trends and stuff can be transferable, and so we can definitely be talking about like that type of thing. But I think like we can be working up to this type of problem where you have like a lot of complicated data and you're trying to find trends.
So let's do this then. So you just told me what to do.
Okay.
So let's do this. On Friday, and that is yours. On Friday, I want you to include in your IPPs for the following week. I want you to include in a do now and in life work. I want you to include scenarios where scholars have to identify trends and patterns using data tables.
All right.
Let's do a do now problem like that and life work. And I want you to create 3. I want to see